This is a weekly summary of interesting news that is relevant for my lectures at the Eastern University of Applied Sciences in Switzerland. My name is Thomas Bocek, and today we will discuss 5 topics. The first topic is about supply chain attacks. It's the following article here. This article is about the first successful worm attack in the NPM ecosystem that compromised over 500 packages, including the popular TinyColor with over 2 million weekly downloads. The malware uses a sophisticated 3.6 megabyte Webpack bundle. The analysis is in the article here. So down it tells you how it's built and what it's inside. Very interesting article. And this JavaScript payload executes during npm install via hijacked post-install scripts. And what makes this attack unprecedented is its self-propagation mechanism. It automatically queries the npm registry to find up to 20 packages owned by each compromised maintainer and force publishes malicious patches to them, creating a cascading infection across the ecosystem. The attack focuses on credential harvesting across major cloud platforms using repurposed tools like Trufflehawk to scan file systems for AWS keys, GitHub tokens, and other sensitive data. It specifically targets AWS Secret Manager and Google Cloud Secret Manager APIs to steal stored credentials. The malware injects itself into GitHub Actions workflow that automatically steal all repository secrets to a command and control endpoint whenever code is pushed. Notably, it only targets Linux and macOS systems and deliberately skips Windows environment. So times are changing, malware targeting has shifted. Historically, it focused on Windows, but now targets Linux and Mac OS systems. The attack is a significant evolution in supply chain threats because of its worm-like behavior. One compromised package can automatically infect an entire maintainer's portfolio, which then spreads to their dependencies and so forth. The malware creates a public repository called Sai-Ulut in reference to Dune's giant sandworms, and this public repository in GitHub contains stolen credentials, making the stolen data accessible. And here in this next article, this is the side of the author of TinyColor. The TinyColor maintainer wasn't directly hacked. Instead, attackers exploited a shared repository where the author had collaborated previously, and the repository still contained a GitHub action secret with a broad scoped npm token that could publish to multiple packages. A collaborator with admin access force push a malicious Sai-Ulut branch containing a GitHub action workflow that immediately executed, no review required for admins, and stole the npm tokens. Interestingly, a couple of days ago, this article is complaining about the lax npm security published just days before the TinyColor attack materialized. The author argues that Microsoft should be considered a bad actor due to their negligence in securing the NPM ecosystem after acquiring GitHub in 2018 and NPM in 2020. He traces the problem back to his 8-year-old proof of concept, demonstrating how post-install scripts could execute arbitrary code, warning that NPM had become the largest and easiest way to ship malware. His frustration centers on Microsoft's failure to address fundamental security flaws despite having the resources to do so, leaving developers exposed to supply chain attacks that have evolved from targeting cryptocurrency to stealing maintainer credentials. The timing is interesting. His warning about post-install scripts being a ticking time bomb proved accurate within days. The article's central thesis that Microsoft's ownership has created a security vacuum rather than improvements appear valid by the tiny color incident. And for that reason, I strongly suggest to use a containerized environment. And I'm also using pnpm, which does not run post installs automatically. And this brings me to the second interesting news of the week. It's the release of PrevelteKit. It's the following site here. So I released my front-end framework PrevelteKit, which is a minimalistic web framework. It's under 500 lines of code that combines Svelte 5 with build-time pre-rendering to create single-page applications that can be deployed as purely static files. Unlike full-stack meta frameworks like SvelteKit, Next.js, or Nuxt that requires a JavaScript runtime in production, PrevelteKit generates pre-rendered HTML at build time using JSTOM and RSBuild, then hydrates the content on the client side for interactivity. So here is the classic SSR server-side rendering with, for example, Next.js. Then we have here the single page applications where we see that there is first a white page, then the content loads, and this approach we already see initially the layout and some static content, and then the rest is fetched. So this is the current approach in PrevelteKit, and this is the comparison to the other ones. And from an architecture point of view, this separation, I think it's much cleaner because the front end requests data from the backend via a dedicated API endpoint, treating the front end as purely static assets that can be served from any CDN, while the backend handles data operations independently. I will talk about this in the UpArch lectures, but I want to mention that here I'm using npm, and for example, when I do an npm install, we see that here those post-install scripts are ignored, and I have to actively approve these post-install scripts that they have the permission to run on my system. So this is already a bit a better behavior than pure npm. And I also have examples how to run this in a Dockerized environment with live reloading. The next article, it's a tutorial. It's the following site here. This tutorial demonstrates building Docker-like containers from scratch using only standard Linux tools. The tutorial walks through the complete process, creating isolated mount namespaces, preparing container rootfs, populating pseudo file systems, handling mount propagation to prevent events leaking to the host, using pivotroot to switch to the file system, and hardening by making sensitive paths read-only or masked. And it explains why each step matters. For example, PID namespaces ensures PS shows only container processes, and UTS namespaces allow containers to have their own host names. So in the end, you know exactly how container isolation works under the hood. And I'm showing a similar approach in my distributed systems lecture, and I'm going to take a look at this tutorial, what I can improve for my upcoming distributed systems lecture in 2026. The next article is about cryptocurrencies. The markets are down because people are nervous and selling. Bitcoin ETFs had money flowing out instead of in, which usually pushes price down. Plus, big traders took profits and reduced their positions, especially during low volume weekend trading when price moves get amplified. And the main reason why now these markets are in red are the usual suspects. Fear replaces greed, less institutional buying, and uncertainty about Federal Reserve's interest rate decisions. When 1.7 billion worth of leverage position got liquidated, it was forced to sell, it created a domino effect of selling pressure. And there's no single dramatic news event, just a typical mix of profit taking, reduced demand, and nervous sentiment that happens regularly in the crypto market. The next article, it's the following article here. It's an interesting development with respect to multikernels, and this RFC proposes running multiple Linux kernels simultaneously on one machine, with each kernel assigned to specific CPU cores and communication through custom interrupt mechanisms. While the author claims benefits like better isolation and resource usage compared to VMs, this approach adds more than 1,400 lines of code to solve problems already handled by existing virtualization technologies like KVM. The proposal appears to reinvent hypervisor functionality within the kernel itself, which raises questions about whether this complexity is justified when mature alternatives already provide similar isolation and resource management with better stability and support. So it's basically the functionality of a hypervisor here in the kernel. And I'm not sure if merging the core functionality of existing virtualization technology like KVM into the kernel is a good idea, but it's interesting from an architectural point of view because it eliminates the traditional user space kernel boundaries that hypervisors typically manage. Very interesting development, not sure if it will land in the Linux kernel. The next article is about GenAI. It's the following article here. And here the author argues that AI has not democratized coding as initially predicted, but instead has made senior developers more powerful while creating challenges for junior developers. The early narrative suggested companies could replace expensive seniors with cheaper junior plus AI combinations, but the reality shows that AI strengths, generating boilerplate code, automating repetitive tasks, and rapid prototyping are most effectively leveraged by those who already understand what they're building and can properly evaluate the output. AI's current limitations expose why senior remain essential. It struggles with code reviews of edge cases, and also important the architectural design, security consideration, and choosing appropriate abstractions. When juniors use AI without sufficient knowledge to evaluate the result, they risk produce buggy, insecure code with poor architecture that accumulates technical debt. The author notes that AI lacks true reasoning ability and relies on imitation, making it non-deterministic and requiring human oversight for every line of code it generates. Rather than replacing human expertise, AI currently amplifies existing capabilities, benefiting those who can already distinguish good code from bad code. And here I disagree with the claim that AI primarily benefits seniors. In many domains where I lack deep experience, I essentially function as a junior developer myself, and GenAI allows me to quickly access expert knowledge and best practices in these unfamiliar areas, effectively accelerating my learning curve. While AI certainly amplifies the capabilities of experienced developers, I believe it provides equally significant benefits to juniors by giving them rapid access to domain expertise, code examples, and architectural patterns they might not otherwise encounter. The key difference may be that seniors are better positioned to critically evaluate AI outputs, but the knowledge transfer potential for juniors is substantial. The last article is about tokens in the Swiss financial markets. It's the following article here. The Swiss Banking Association has completed successfully a proof of concept for deposit tokens. PostFinance, Signum Bank, and UBS collaborated to demonstrate legally binding payments using bank deposits on Ethereum's public blockchain, although the token triggered off-chain conventional payments. The deposit token system allows traditional bank money to be represented on blockchain infrastructure, enabling programmable payment through smart contracts that execute only when specific conditions are met. And this addresses current limitations in Swiss payment systems which cannot integrate with blockchain ecosystems. So this is for sure an interesting development. It's just a proof of concept, but they're using now public Ethereum blockchains, which is for sure better than what they used in the past, where they used this public permission blockchain ledgers. Now they're using a public one. I think this is a step in the right direction. See you next week.